Hello, everyone, and welcome to my software as a service product creation and selling speedrun. So, what am I doing here? I am a software developer and I want to create a software as a service. Simple as that. And I'm going to speedrun through it to create it, and I'm going to record myself doing it and share it on YouTube. So, let's get down to what matters. I have nothing, I have a Notion, and I have Python installed and Poetry installed. So I'm kind of like starting from scratch. I have nothing. Okay, so what's the product gonna be? The product's called Wenday. So the name is Wenday. And the purpose is to schedule meetings automatically to solve the lack of time problem. And so what does that mean, JS Paint? So let's say you're working at a company, and this is just for companies. So target audience companies to use this internally. So let me give you an example. Let's say you're one person, and then you have some colleagues, and you want to schedule a meeting with all of them for next week. I say, hey guys, I need to talk to you next week. Do you have time on Monday? And the guy's like, yeah, sure, I have time. But the other person like, oh, I don't. Monday's is full for me. Oh, what about Tuesday? Oh, Tuesday I'm not good. Oh, what about Wednesday? Oh, Wednesday's fine. And then this person says, I can't really do it on Wednesday. So there are issues here is that it's very hard to schedule meetings and find compatible times for everyone. That's problem number one. So let's just call it current problems / adversities. And number one is it's hard to find free time for everyone to have a call. And this is particularly relevant in a mid to big size company, not a small startup. And number two, there is a lot of reluctancy to change already scheduled meetings. So the thing is that, let's say this person wants to schedule one for Tuesday, and everyone's available on Tuesday except for this person, because it says, oh, I am already fully booked on Tuesday, because he has a meeting with let's say some other guys here. But the thing is that maybe they could all move their meetings to another time to make space for the meeting of these four people. But people are like super reluctant to it because it takes time, and you just need to talk to everyone. It's a very tedious process if you think about it. And the solution to it, I propose something different. So what I propose, let me just open JS Paint again. So let's say you say something like next week I need a 1 hour meeting with Alice and Bob, the most famous Alice and Bob. If you guys are not familiar, like Alice and Bob, they really show in like examples. Those are like the placeholder names, like the common ones. And you just say this. Let's say you just say, next week I need a 1 hour meeting with Alice and Bob. And then And this is, Peter says this. And then Alice says, next week I need a 2-hour meeting with Bob and Zane. And Zane, I need a 30 minutes meeting with Alice and Rachel. And so everyone just says this. They just declare who they need to meet up with and then declare how long it should take. And then let's say Friday night comes, so then you have the weekend and no one's working, and then there's a computer algorithm that tries to figure out automatically the times that would match all of these requests, and then would create the meetings automatically. So let's say you only figure out when you're going to have the meetings during the weekend, but you're not planning them beforehand. So this is actually cool. So there's no precedence or priority over the meetings that were scheduled before, and this really solves the problem. So let me just write it down. Solution: ask people to declare their meetings abstractly. So it's like how long it should take, who needs to be involved, and let an algorithm decide that automatically. New keyboard, I'm like not spelling things right. An algorithm decide that automatically during the weekend. And then the other question is, how do you know? What if people already have meetings set? Because let's say Zane needs a meeting with Rachel, but Rachel already has a meeting scheduled like a month ago. It's already in her calendar. So the solution would be, let's imagine that this company uses Google Calendar. They're using the G Cloud suite like for Gmail and all those things, Google Docs. So what happens is this algorithm would go automatically into Rachel's Google Calendar and check Rachel's availability, and it would take that into consideration, and it would not double book Rachel. So details, the algorithm has access to Google Calendar of every employee. So yeah, it seems like a simple product, and I think honestly, I would use it. The purpose of this is not for me to create the next revolutionary product and be rich. It's just for me to build something that actually serves a purpose. So yeah, this is the product, and how will people use it? It will be a web app. Simple as that. Tech architecture. So I'm not going to get too complicated with this. I'm just going to be as simple as possible. So it's going to be one front-end app in React. If you ask me about Next.js, this is not like a public-facing website. This is like private, so we don't need like SEO optimization or anything like that. So React is more than enough. With TypeScript, and then one backend app So it's like HTTP, Rust, gonna be Python, Fast API. One database. It's gonna be a PostgreSQL, and I'm gonna use SQL Alchemy to interact with it, and Alembic. And then, so there's this algorithm. So for now, the algorithm is going to be like the beating heart of it. So the algorithm will be coded in Python, because I love Python, and I think it's the best language for this kind of like problems and this kind of applications. And it's going to use NetworkX and also Google OR tools. And the algorithm could be living in its own microservice, but just for the sake of simplicity, I'm going to put it inside of the database, of the backend, not inside of the database, inside of the backend, just so I don't have to orchestrate more than one thing. And just because the objective of all of this is to build SaaS and try to get some users. So I'm even gonna write here, like, not the objective to build amazing, super complicated code, to build something super scalable, to build something with a lot of features. MVP SaaS, just to make it very obvious. And what do I mean by this is that I could go deep down the rabbit hole of making something super amazing and efficient, but that's not the purpose. The purpose is to build something that works and can be used. And then potentially later on, as things get adopted and used by clients or users, then we improve based on the feedback that we get. Okay, so let's get started. So let's get started with the algorithm. So the purpose of the algorithm is to do combination solving. And what is like a combinatorial problem solving? To do that, there's something called Google OR tools. And if you don't know what this is operation research tools. And they have some tools that assist you into solving operation research problems. And those include optimization problems and combinatorial problems, satisfaction problems, and you can even see here CP SAT. This is the SAT problem, which is pretty much what we're going to do right now, is create a problem that can be converted into SAT. SAT problem. Boolean satisfiability problem. So we can even look at this. This is like x1 and x2, or x1 and not x2, or so you just want to satisfy everything. And what is the combination of those variables that you can do to satisfy it? So in our case, let's imagine that we have a timetable. So this is Monday, Tuesday, Wednesday, Thursday, and Friday. Friday. If you guys don't know, Rebecca Black is now a DJ and she has a boiler room. Okay, so this is Monday, Tuesday, Wednesday, Thursday, and Friday. And it goes from, so this will be like some tiny chunks. No, just like a normal timetable as when you had in school. So this is like 0, 0, 0. Oh yeah, it's too big. 0, 0, 0, 0, 0, 0, 30, then it's 0, 1, 0, 0, all the way to, and then we have like 1 o'clock in the afternoon, then 1 o'clock. So, and it keeps on. It's a gift that keeps on giving. So you pretty much do all of this. And what do you have here is just slots. And your problem is that you want to find slots where you can match. Let's just do this. So let's just color this. So you need a 1 hour meeting. So a 1 hour meeting would be this. And then another solution would be, okay, 2 hour meeting. So it couldn't be this, you know, because this already, we cannot have overlaps. So let's randomly say, okay, this is good. And then this one's a 30-minute one. Yeah, it couldn't be here, of course. Let's just put it here, for instance. And yeah, so we need to find places for these ones to exist. The difficulty here, like it seems pretty obvious here, but the more meetings you have, the harder it will be. Plus there will be already some pre-scheduled meetings. So, for instance, Bob already had a meeting here scheduled. So yeah, we know for sure that we couldn't put this pink meeting here. So our approach here is going to be to convert these slots of 30 minutes, and I'm going to use 30-minute slots. We could use 15-minute slots, but let's just, for the sake of simplicity for now, just use 30 minutes. These ones will be slots, and those slots will be represented by integers. So let's say this is slot 0, and this is slot 1, slot 2, and you just continue, and you will have, if you have 24 hours in the day, then you will have 48 slots of 30 minutes. So this goes all the way to 48, then Tuesday starts with 49, all the way to 96, and all the way to Friday. And then what you need to do is create variables that match these slots. And by the way, if you guys are not familiar with operation research and integer programming and constraint programming, this will be all new to you. I think I should get started and just code it and see where it takes us. Okay, so code and Wednesday. And now make directory and let's just call algorithm for now. Code algorithm. And here we are, VS code. So get out. Poetry in it, I guess. Wednesday algorithm. Yeah, yes, this is me. Yes. Yes. So right now I just want to add Google OR tools. So tools of Google. And now to install. No, I missed that. And by the way, there's other packages for this. There's one called Pulp. I think there's one from SciPy. I don't know. They all kind of do the same. Come on, this can't be that hard. Let's just try. OR tools. Development dependencies. Actually, yes. So I'm going to do black MyPy Oh no, I messed up. Oh, now I need to do everything again. Oh, sucks. And a algorithm. It's when you get for trying to do things in a hurry. 3.12. Yes. OR tools. 0. Version constraint. Add a package. Let's leave it blank right now. Do you define the development dependencies interactively? Yes. Black. That's it. Add a package. MyPy. No version constraint. iSort. No version. Flake8. Flake8 is the lenta. And then PyTest for tests. And I confirm the generation. Yep. Okay, so now Poetry install. It's creating the virtual environment. And now we wait. So I'm just going to create a main.py for now. And let's see. Select interpreter. When the algorithm. Yep. Guess this is it. Valid Python environment is such a come on. Okay. So Google OR tools. I've built something recently. I don't think I have it here though. I'm gonna use my best buddy, ChatGPT. Can you create Google OR tools constraint problem solver example in Python using integer variables? Yeah. Okay, so CP model, new environment. Okay. Now I think I can just copy this. Install node root. Okay, so now Poetry and rest call path. Okay, this is the environment. So I need to get this environment and pass it to VS Code. What? What's going on? Command palette, select interpreter, enter interpreter path. Okay. Yep. It's working, so let's just run this with a debugger. Python debugger, Python file. Come on. Is this like a, oh, okay, optimal solution found. Okay, so just to give you guys like just an introduction to what happened is that I created 3 variables x, y, and z. Lower bound is 0, upper bound is 10, so they can be between 0 and 10. And then the constraint is that the sum of all of those variables needs to be lower or equal to 10. The subtraction of x minus y needs to be bigger or equal to 2. So just some constraints, and then it finds the best solution. It tries to maximize the values. So the objective function is here. It wants to maximize x plus 2 times y plus 3 times z. And what I want to do here is to remove this and see what happens. Yeah. So it found this, it didn't maximize. So remember that it found this one and the objective was 20. So it's like, yeah, great. Here I removed the objective function. So right now we're not trying to maximize anything. By the way, you can also do minimize, just just to give you some new stuff. Minimize. Yeah, in the case of minimizing this, it actually tries to get these variables down as possible. The thing is, like, x minus y needs to be bigger or equal to 2. And the solution is this, so x equals 2. So it satisfies this constraint. If we change this to 1, look, x equals 1. Because it really minimized a bit more. And the objective is 1. And it's not 2 anymore. So in our case here, if we come here, I don't want to maximize or minimize anything, at least right now. And later on, I'm not even sure it's going to be possible because of some details regarding this technology. But I just want to find a solution that is feasible. Not optimal, but feasible. So this is going to go. And so let me just remove this. And what I need to do is create variables and create constraints of those variables. So right now, let's kind of just create this example that we have here, simple as possible. So we have meetings. Oh, okay. So now poetry add the Pydantic. So I want to create a base class. So I'm gonna do some models .py here so I can create. So from Pydantic import base class, base model. Yeah, sorry, not base class. And so class meeting inherits from base model. And meeting will be duration, and it's going to be an integer, and this is amounts blocks of 30 min. So if duration is 1, it means it's 30 minutes. If duration is 2, it means it's 60 minutes, 1 hour. There's one way that we can assert that this is bigger than 0. I'm not going to get into that right now. Duration and people. List of string. As in, this will be a list of emails, so at company. So actually Alice at company.com, you know, and then Bob at company.com, something like that. Okay, so now we have meetings is a list of meeting, and now we go meetings duration is this one is 1 hour, so it's 2, and people is so it's Peter, Alice, and Bob. So I just need to add Peter here. Actually, let's do something here. Alice. Alice email. Peter. Bob. Zane. Rachel. So yeah, we have these emails. So people will be Peter, Alice, Bob, and this is like meeting number 1. So if we go, we have 3 meetings. So it's Alice, Bob, and Zane. Alice, Bob, and Zane. Why did I think about Zane though? I think it's because I recently heard that Zayn Malik is a Yu-Gi-Oh player. Okay, so it's 2 hours, it's gonna be 4. And then last one is 30 minutes with Alice and Rachel. So Zayn, Alice, and Rachel. Yep, meetings. So these are the meetings that we have. So now we need to create variables. Do we need to create those variables though? No, okay, so we have these slots. So our variables are between 0 and the upper bound is so we have 5 days and 48. So it's 5 times 2 times 24. So the upper bound of a variable, so each variable represents the time slot of that meeting block. So a meeting block of 30 minutes can either be on 0, on 1 or 2, all of those. The name, this, we'll get to it later. Let me just comment these ones out right now. So for meeting in meetings, and for meeting block in range, meeting dot duration. So let's see, we need to create a variable for it. block variable. Current meeting block variable. It goes from 0 to all of this, and the name is, I think we can just go with a format string. Meeting. Let's just give it an ID. Yeah, let's make the ID a string, doesn't matter. Meet1. This is going to be meet2, meet3. So I can even just go and do meeting dot ID, then block meeting block var. Yep. So the current meeting block variable. So we're creating variables for it. And what we need to know here, I think what we should do is, okay, so meeting bars. And this is going to be a list of int var, and this is, I guess, cp model dot int var. Yeah. Yep. So now, lower bound, upper bound, name. I like having the names of the variables, the keyword arguments. Okay, so now current meeting bars. Up. And now we have them all here. And then I'm just gonna do all meetings bars ever. It's gonna be a list. I can even do this right here. Extend current meeting bars. Okay, so let me just run this. And let's see what we have. So we are currently at meet1, and how many blocks we have? We have 2 blocks because the meeting has duration 2, so we have 2 blocks. And then we're going to append them all here. So I think we can start adding constraints already. So one of the constraints that we have is, so let's just run this. Let's just run this and see what happens. File expression. Oh yeah, it's not really gonna work. So all meeting bars for view in meeting bars ever solver value of VVV. VVL drizzle. VVL drizzle. I figured it did it. It did it. Wow. No solution found. Oh well. Okay, so something's definitely wrong here. So what went wrong? Let me check ChatGPT again. So we define the variables, we create constraints, then we don't need a maximization function. Well, do we need a constraint? I don't think we do. So status is for CP model for, and feasible is number 3. Feasible is number 2. What is for optimal? Oh, I was stupid. Yeah. Should not have removed that. Okay, so there's no objective, so I think we can remove this. So x, I don't want to do x, so it's going to be VVV. Meet1 block 0 var. Okay, so all of them are 0. So the first thing is that we cannot have overlaps. So so it's like for I in range length of all meeting vars ever, and then so we need to say that the first one needs to be different than the second, the first one needs to be different than the third, all of that. So, and then for j in range of I plus 1, I guess. Yeah, it needs to be I plus 1. And then length of all meeting vars ever, model dot add is different than, I'm just gonna print y and j just so we have a look at what's going on. Yeah, so 0 needs to be different to 1, 2, 3, 4, 6, 1, 2. So we're not like repeating things, and then 5 needs to be different than 6. Yeah. So we found, okay, optimal solution found. We can see that all of the solutions that we found are different. This is one thing. However, there's one thing that's weird here. Coincidentally, all of these variables, they're sequential. So if you look at meeting 1, the first block 0 is 6 and then 5, so that would mean something like 0, 1, 2, 3, 4, 5, 6. It would be something like around here that it's building because it's including block 6 and 5. So it makes sense. But there's nothing here that tells us that these blocks need to be sequential. And this is something that we need to be, we need to ensure that. So, the way that we ensure is that current meeting variables, now, let's say we're over here and we do for I in range current length of current meeting blocks, current meeting vars, -1, and then we do model dot add current meeting vars of I needs to be equal to current meeting vars of I plus 1 minus 1. Okay, so what's going on here? What does this constraint mean? And I'm gonna comment this. Meeting blocks need to be sequential. So in this specific example, let's say we're talking meet block 0, and then we have meet 1, and so on. Let's say we have meet block 2, So one solution, let's say if this one is at 6 on the block 6, then this one needs to be a block 7, this one needs to be a block 8. So what this means is that block 0 needs to be equal to block 1 minus 1. So, what did I do? Did I press? Equals minus 1. Yeah, 7 minus 1 equals 6. So this is what I'm doing. The next block here, minus 1, equals the previous block. So now, let's run this. So yeah, now we see meeting number 1, block 0 is at 4, then the next one is 5, then 1, 0, 1, 2. They're sequential. It's good. So it's done. It works. There are no overlaps, and all is good. But the magic, the example that we have here doesn't really do any justice. So the beauty here is if the scheduler can schedule a meeting at the same time as another meeting, because the participants of both meetings are not having the same meeting, so are not in both meetings. So what does this mean? So Zane needs to meet with Alice and Rachel. Let me create a new one. So Zane needs to meet with Rachel. So let me create another meeting that Zane needs to meet with Rachel. Duration 1. It's just 2 of them. And how shall I put this? Because I know that this works, I just wanted to show you guys on video. Okay, so one thing that I'm going to do right now is to really reduce the slots. So let's say instead of 24 hours, we only have 10 hours. Or like, we only have 5 hours. And it's just one day. So this is only for Mondays or just Tuesdays. So let's run this. Optimal solution found. Yeah, it still found a solution. And let's say, let's just shorten this. It's 5 hours, 4 hours. There's still an optimal solution found. There are no overlaps though. It must come to a time that there's no time for all of this. No solutions found. Okay, so we're getting closer. I'll just remove this print statement here. Don't need that. Okay, so we have 3 hours. Well, this is obviously impossible because there's a meeting of 4 hours. Oh, let me go back to 4 hours. Oh no, this is not a meeting of 4 hours. This is a meeting of 2 hours. 4 blocks of 30 minutes. So let me put 3 hours here. So 3 hours might be impossible because this one is 2 hours, then 3 hours. So yeah, Alice is in 3 of those, you know. Let me remove this one. Okay, so we have, this one is 1 hour, 2 hours, and then 30 minutes. And there's only 3 available hours in this day. And it found something. It found time for all of them. However, there are no overlaps. And what I want to do here is I want to create an overlap just to show that it is possible. meet 4, meet 5. This is Peter and Alice. Let's see if this works. Solutions found. Peter and Bob. Yeah, because Bob's already booked for 3 hours, but Peter and Rachel. Oh, I'm so stupid. This is where things are wrong. So, we're saying that all variables need to be different, but this is not true. This is absolutely not true. And this is my mistake. So, first of all, I totally forgot about this. There's one step here missing. Of course, all variables need to be different if all the people are, well, no, not all variables need to be different. Of course not. Why don't they need to be different? So what we need to do is we need to say that okay, so let me create people vars. So this is going to be a dictionary of string and then cp model dot invars. I'm glad I did this thorough testing. So here current meeting blocks and then all meetings extend. So now what I need to do is I want to get all of the Peter variables together. So for meeting dot what was the people? So just call participants in meeting dot people. I should change people to participants. If participants not in people vars. People vars, right? Yeah. Dot keys. Then what's going on? A minute's not defined. People vars. Oh, people. Of course. And then people vars of participant equals empty array, and then that extend current meeting vars. So this is wrong, and what is right is for a person or participant in people vars dot keys. I know you don't need to do the dot keys, but still I like to be verbose about it. So this is the for I in range length of per participant vars equals people vars of participant list. Declare the variable correctly. In length of this. I guess I need to do a -1 here. Do I? All meeting vars. No, I don't need to. Do I need to do a -1? I don't think so. Okay, so now we see that it did find a solution, and we can see that this one is on slot 2. So meeting number 2, block 0 starts on slot 2, and meeting 5, block 0 starts on slot 2. Meeting 4, block 0 is on slot 0, slot 0. So let's look at the definition here. So meeting 1, so the duration makes sense, and it has Peter, Alice, and Bob. And meeting number 4 as Zane and Rachel. So we can see that this block here, this can be simultaneous to this one, because none of the people here are included here. And the same goes Peter and Rachel. Yeah, same thing with block 2, it's Peter and Rachel. Okay, so this is, need to take a phone call. Okay, I'm back. Okay, so, well, I don't know where I was. Okay, so what it feels like, it's that none of these, when there's overlaps, it's not when people should be in both places at the same time. And let's just add this one, see what happens. Most likely it will fail. Oh no, it worked. Let's see. Oh, yeah, meet free. Okay, good. Zane, Alice, and Rachel. Meet free. It's at slot 6. So it found a slot. So this is the beauty of this, is that it really tries to match if possible. And we don't really need to write an algorithm that creates a logic. We just need to define the constraints. Let's say I do this. I'm just increasing. No solution found. It's okay, because it's impossible. Now that I increase the time, I think it's because of Alice. Well, it's because, well, Alice is in all of them, isn't she? So we have 6 blocks available here. Yeah, 3 times 2 times 1 is 6. It's not really that. Actually, it's not that we have. It's, I made a mistake here, because our upper bound, the upper bound is inclusive. So what we need to do is we need to do this -1. So it's going to be all of this -1. Just for our, because we're going from 0 to, so if we have 6 slots, we go from 0 to 5, because 5 is inclusive. So no solutions found. yeah, I think that if I remove this, yeah, but if I include this even with 1, it's gonna be no solutions found, because if we have 6 slots available and we need 7 slots for Alice, well, can't happen. However, if we remove Alice from here, then yes, a solution can be found. Yeah, okay, so you guys get the picture. So all is good. What I think that I need to include now is that let me just go back to the example that we had, which was Peter, Alice, and Bob, Peter, Alice, and Bob, Zane, Bob, and Alice, and then Zane, Alice, and Rachel. And I'm going to this, and I'm just gonna put a breakpoint and check if the math is mathing, you know, if we have the right number of variables. So it's what? 7. Meaning vars. Oh no, this was just stupid when I did. So if we divide this, it should be 2 times 24, 47 ES. Is this correct though?
I'm not sure this is correct.
No. This is not correct. So we need to do the -1 in the end. This is correct. So this is like if we have 0 to 239, means we have 240, and 240 divided by 2, this means we have 120 hours divided by 5, 24 hours. Okay, so this is the correct upper bound for all the variables. Okay, so what are we gonna do now? We need to, well, first of all, I think that realistically, no one's gonna schedule calls for midnight and then 1 a.m. and then 1 in the afternoon, so it's not realistic. So we need to have something such as, let me move this here. Meetings, and then we have daily working hours start. And let's say people start working at 9 in the morning, which is 9 times 2. The block and the end is, let's say people stop working at 17. So end. See if this is right. So if you have people start working at the midnight at 0, if people start working at 1 in the morning, it's 1 times 2. Yeah, I guess this is. And daily working hours end. Yeah, it's like this. So I guess that what we can do is we need to exclude variables from being in numbers that are not in this range. So let's just do invalid hour blocks due to working hours. Let's just call it invalid slots. Yeah, I'm mixing up the names here. But I think we should call slots the times. So this is a slot, this is a slot, this is a slot. And then the block is, I guess, all of this. I don't know. It's new to me. Okay, so let's just say for I in range, and it's in this range, and if I think that we need to do like an integer division or like a remainder division. If I divided by 24 times 2 is smaller than or bigger or equal than the end, then okay, so let's see. Okay, yeah, I is 0, of course, and then 1 all the way to, let's just see how far. What's the result? Valid slots. So we have 0 all the way up to, we should have it all the way up to 18. Huh. All of the numbers are here. It shouldn't be though. Oh, I did something wrong here. So if it's lower or if it's higher. So what happens? Is there any time that this doesn't happen? Else print I'm just going to run the debugger to check if it ever comes here. No, it doesn't. Okay, so oh no, I think this is the wrong operator. $18. Let's go. So invalid slots goes all the way 17 and then 34 starts again 34 because it is 17 times 2. And then it should continue all the way to 65 and 65 because that is 17 times 48. Yeah, 65. Okay. So this works. So what we need to do now is we need to say that all of these variables needs to be different than all of these slots, of these invalid slots. So I think I can do it immediately here. or here at the end. So variable cannot be in an invalid slot. So, and for invalid slots invalid slots due to working hours, model add must be different than this. Let me remove this print 7 thing here. Huh. Oh, what do you know? It didn't work. Why didn't it? Slots. Why? Needs to be different then. Oh. Okay. Yep. So here it is. So we already added the working hours, the daily working hours. And what the other thing that we need to add is so let me create a model for for people. So class. I'm going to change people to participants. Participant. It's going to be name, string, email, string, and then already booked slots. And this is going to be a list of integration. Defaults to none, I guess. So Alice email, so I guess that right now I need to do all of this. So Alice equals participant and name is Alice, email equal Alice email, and then already booked slots. Let's just talk like this. So Bob, Zane, Rachel. By the way, I chose Rachel because she was a recruiter that found me a very nice job a while ago. It's the only recruiter that I ever loved. Okay, so now people. I think this is good. So participants. So we need to change these participants to remove this underscore email tag. And here, meeting dot participants here, participants, extend, participant not name. Name. And now, let me remove this ChatGPT thing. Okay. Okay, so we have this, and now what we need to do is for each meeting we need to check the slots that are already booked by these people. So let me just do something here. So let's say Alice is already booked here. It's Peter, Alice, and Bob. Peter. So Alice already booked here, Peter's already booked here, so we know that this cannot be the slot. These cannot be the slots. Let's just do this to start with. And so for meeting impossible slots due to prior engagements. It's going to be a list of integers. No, it doesn't need to be. It can be a set, actually. And now for participants in meeting participants, and for prior engagement in participant dot, what was it, already booked slots. It's just already booked slots. Set dot add already booked slot, and then when we create a variable, invalid slot, I think I could just put it here. Variable. And then variable that cannot overlap a prior engagement. So for let's just call it possible slot. Possible slot to prior engagements. This is an integer. So meeting block 0 and 1 cannot be 22 and 23 because Alice is already booked on the 22, the 23. And this is like something that someone already has in their calendar, something outside of this scope. What? Really? If the add for set objects does not apply to an object, it doesn't. Really? So how do you do this? I never really work with sets that much, so Python set of integers.
Python sets. Create an empty set, and how do we add stuff to? Add 32. It's the big deal. Free. Oh, I'm stupid. I'm not stupid. I should have more self-love. I'm just like speaking at the same time that I'm coding and well. Okay, so yeah, 22 and 23, they did not happen here. And we can see that 23 is actually being used on meeting number 2, which has Zane, Alice, and Bob. Yeah, but doesn't have Peter. But let's say Bob 24. Run. Yep. So you guys can see that this actually works. So honestly, this, I might be overreacting, but this is something you can make money of. This is already helpful. So let's just go back here. Product on a Kanban board. Write tasks. Yes, that's number 1. So in progress. And this task is going to be named write the algorithm, and then new page is going to be integrate with your calendar for fetching data. Integrate with Google Calendar to create events. Write a backend for this, and write a front end for this. And of course, post this in the cloud. I guess this is all it really is to have a functioning product. So we can say that the algorithm is in progress. So what I want to do here, right now we have a script, so it's like cool, but I think that we should move this into something that is a little bit better. So we can actually move this into a function. So that solve find available slots, and it will return algorithm result, and the algorithm result, let's define it here in the models. The base model, it's a status which is going to be int, so success 1, failure 0. Actually, success is Boolean, and how? What do
return. No, we pretty much need to return the numbers, but might as well return the meetings and the slots. So, meeting after algorithm. Let's just call it like meeting after algorithm. And inherits from this. So it has everything a meeting has, but slots. And meetings is a list of meetings after algorithm. Yeah. So I guess that we need to indent all of this. So now we just need to meetings listed meeting, and then I'm gonna move this already. I want this to get out of my way. I'm gonna create tests. Test algorithm .py. Get test algorithm. Okay, so. And yep, and right now, I want to do find available slots here of meetings equals meetings. Daily working hours start. And exclusive. Okay, good. Done. And now we assert result dot success equals true. Oh, we could just remove this, but I don't know. I like keeping stuff here. So let me just keep this. And now we need to return algorithm result success equals false. And here and the worst part here is that we need to get these variables and insert them back into the meetings. Sucks. So I guess that what we can do, just to make it very, very simple, meeting by ID, the dictionary of string and meeting. I guess that we can do
meeting dot id. Meeting in meetings. Guess this works. Meeting by ID. And then here meeting, yeah, I don't want to do meeting, I want to do meeting after algorithm. Yeah, this is probably not the best way to do this, but duration and participants and ID and slots. So okay. So what I do here is for just gonna put a breakpoint at 0. I think that right now we can do some configure Python tests, pytest tests directory. Okay. So I'm gonna run this. Why the hell did it fail? Unhashable type meeting after algorithm. Really? God. Really? I'm surprised. I thought I could hash anything. This sucks. Oh! Of course. Okay, good. So if we come here, meeting after algorithm, yeah. Okay, good. So now we have VVV for VVV. So I think that we can go for the string value of it. str of VVV. Okay. So what we need to do is str of VVV dot strip this. So the meeting ID is this one, and then we go for meetings algorithm by ID, and we have the meeting ID dot slots. Yep, slots. Dot append solver value. And then what we need to do is algorithm result meetings is equal to meetings after values. So just key error M. Oh, split, not strip. Yeah, I'm a pervert. Yeah, good. Failed again? Oh, it passed. Okay, so let me just come here. And then insert, no, I'm just gonna do some stuff. Length of result dot meetings equals length equals 3, I guess. And then insert meetings 0 dot slots 2526 equals 2526. I guess I can do the same for the other ones. '18, 19, 20, 21. 18, 19, 20, 21. And then this one, 23. Okay. One thing that I can do is for meeting and results dot things. Meetings. Oh, no, never mind. Well, yeah, no, I gotta do it. I was just getting lazy. For slot index in range meeting dot slots. Just a minus one. Assert meeting assert meeting slots of index slot index equals yeah, that same thing. I just wanted to check if they're sequential. Yep. Okay, so we have an algorithm, we have tests, we have everything. We have the power. I think though I should do a little bit more tests though here, just so it saves me time later on. And so index, yeah, so I don't want to do those tests right now. I'm just gonna trust everything is good for now. I think this is a very good start, and yeah, we can use it as a function. So what we need to do now is we need to sell this, but before we continue, there's one thing that I wanted to do, and this thing uses network X. So let me add this new dependency. So if you guys don't know what network X is, it's something that you create, that you use to handle graphs in Python. So what I want to do here is, let's say I'm working with a
company, and they're using my product, and it's just a bunch of people and a bunch of meetings. And there's a meeting with this guy, this guy, this guy. There's like a lot of meetings. But you can see here that these things are separate. Like, there's nothing connecting this set of people with this set of people. So what I need to do here is I need to be able to separate the groups of people and run the algorithm separately for the groups of people. And why am I doing this? What is the purpose? So in this constraint problem solving, sometimes you get like, there's no solution. There's no solution. It doesn't really tell you why there's not a solution. It doesn't give you recommendations. It just tells you like, there's no solution. It's impossible what you want. So let's imagine that we have like these two groups, and these people here, it's just impossible to book meetings with them because their schedules are just like impossible to match. But the people here, you can actually do it. But if the impossibility on this group, the impossibility here will make the entire solution impossible. But the solutions are kind of like separate, so we might as well separate the groups beforehand. And so let me do that. So main, find available slots, and I just create a different function. It's going to be called separates meetings by groups of people and connected. So we have the meetings. That's a list of meetings. Right now, my return will be a list of meetings. Why? Because instead of having one list of meetings, now I will have different lists of meetings that don't really have connectivity between them. So let me do some test-driven development actually. Test. It's not test algorithm, it will be test, what did I call it? Test meeting separation. Just separation. Let's just do it like this. And let's just say, yeah, Peter, Alice, Bob, Allison, Zane. Let's just do something very obvious. So we have Peter, Allison, Bob, and Zane. So you can see that Zane's connected to all of them. And then we have, let's create some new person, some new people. So Joanna and Sophia. So Joanna is my girlfriend, and Sophia is my girlfriend's mom. For all of you hackers that are interested. Joanna. Sophia. So there's this meeting, Zane and Bob. And meeting 3 is Joanna and Sophia.
And let's actually do another one called Fabian. Fabian is a friend of mine, and he's actually super cool. He helped me yesterday make a music video. He was a Boy Scout, and he helped me make a very nice fire. So we have meeting number 4, and the participant is Fabian and Sophia. So our objective here, so we need to run this, and this will be separate meetings by groups. And meetings, group 1 and group 2. I'm already decoupling them. Yep. And I'm going to say that group 1 equals, I need to assert, equals to this. And then group 2 This makes sense because Peter, Alice, Bob saying Bob, join the Sophia. These need to be separate groups. So how do we do this? So first we create a graph. I'm gonna ask my buddy ChatGPT. I am working with Python and NetworkX. I want to create a graph out of directed relations I have between people. Let's just start with this. Alice and Bob, the famous ones. Here they are. Okay, directed graph, and then we add the edges. Okay. So yeah, we can start by this. And then, yeah, so create graph, and then graph.add edge, and for meetings, and now for person index and range, length of participants, meeting dot participants, and now for let's just say person index 2 and range person index plus 1. I guess that I can also do minus 1 here. And then I say graph add edge between meeting participants person index dot id, no,
name. The email. I'll just do email so I don't. Later on, I'll have to deal with the fact that people can have the same name, but I'll assume that they don't have the same email. Okay, so I'm adding the edges. I don't want to plot this. Okay, so now I want all connected components. It's called connected components, right? Strongly connected components. Is this it? I'm not sure if this is it. Where's Babylon? Okay, no. Weakly connected components. I think this is what I want. The weakly connected components. Graph. Start 1. Okay, let's give it a shot. No idea what's gonna happen. Okay, this is gonna fail. Is there any standard output? Debug console. So just put a print here. And then, there's a new button there. I never heard of it. Okay. Weakly connected component 1, Zane, Bob, Peter, Alice. Then join Sophie and Fabian. Okay, this worked. Perfect. So what I need to do now is I need to... Shit. Sucks. I need to go and get all of them. I'm gonna do this in a non-efficient way. Or should I do it in an efficient way? I guess I'm gonna do it in an efficient way. So meetings by email. It's gonna be a dictionary of string, and then meeting. Then list meeting. And now for meeting in meetings, for participants in meeting participants, meetings by email if participant not in meetings by email dot use. Then I guess that meetings by email of participant equals an empty list, and then I can do this dot append meeting. I'm not sure if this is the most efficient way of doing this actually, but I guess it is. We need to associate them by people, and then so we have all the meetings by the email, and now for the component I need to put a breakpoint here, and I need to do like result list, and then I just need to do component 0, so I just want to get the first one, so I need to get the one from Zane, because like logically Zane's meetings will be the same as Bob's meetings, Peter meetings, Alice meetings. No, this is not true. This is absolutely not true. Meetings by email. Okay. Okay, so for current email in component, and now we do. Okay, this sucks. Current email in component, meetings of email equals meetings by email of current email. Okay, no, this is gonna be good. Meetings, current meetings by ID. It's gonna be a dictionary, string and meeting, and then for meeting in meetings of email. Email. Current meetings by ID of meeting of email dot ID equals meeting of email. Meeting of email. Yeah. So this works. And then result list dot append current meetings by ID values. Okay, so what does this do? This pretty much, it goes by every person. Okay, what the hell happened? Participant not in, where is that? Yep. Results list, it should have two lists. Deck values, I should just convert this to a list already, so. Okay, again. So it has two lists, one for each component. This has. So the first one has meeting, should go for meeting 01 and then meeting 02, and the second one has meeting 04 and meeting 03. Okay, so I guess that if we do this, it's probably gonna fail because it's getting the meeting 4 first. So what's gonna can unpack non-iterable non-type object. Am I returning anything, by the way? Oh yeah, I'm not returning anything. Return the result list. List of meeting. Is it failing? Insertion difference group 1. I wonder what this button does.
gonna check the IDs. Just to fast forward these issues. Well, it was actually this. The hell? Okay, so sometimes it works. So network X doesn't have like consistency in their results, which sucks. So for okay. So for write ID in assert write ID in group 1 and then assert length of group 1 thank you network X for not having consistency. I wonder what goes on in your code for this to happen. Yep. Okay, good. So this works. By the way, is the algorithm still working? It is. And thank you Google R tools for the consistency in the results. Okay, so this is good. This is good. So the next part is for me to build a backend. So I'm gonna come here, Kanban board, write the algorithm. I'm gonna say that this is done. Next part is to write a backend for this. And writing a backend, I'm gonna create some tasks already because I know what it means. I kind of imagine it already. So, backend. That will be, let me see, authentication. Create a meeting. Modify. Backend, so create a meeting.
check all meetings I created. Check all things sent to me. Create, read, update, and delete. Create a meeting. Check all meetings I created. Check all meetings assigned to me. And I guess that one last thing would be, okay, well, database definition. And that's it for now. And then the front end will be very simple. So I can actually start doing front end. Login page. I'm not even considering right now anything else. Like, I'm thinking about doing all the other stuff in back office for now. There will be a lot of back office things maybe in the beginning, because I don't want to do unnecessary user flows. So front end, login page, and then CRUD meeting. Main page with all my meetings I'm involved, plus, not I'm, a user is involved, plus the meetings the user created. By the way, just to be clear, I don't want a user to be creating meetings for meetings that himself is not participating. Or should I? Maybe I should. I don't know. Let's say I'm a manager and I want to set up a meeting for someone, for like a group of people that I'm not participating. Yeah, I think this should be a feature as well. Okay. Okay, good. I think this is good for now. I'm going to take a break. And I hope you guys enjoyed this. And stay tuned for the next episode. Bye.